All right, this is part two of the chapter four review using a chapter test. Problem number 13. If triangle ABC is congruent to triangle DEF, how do you know that angle B is equal to angle E? All right, so seeing how we have already proven that the two triangles are congruent, and now you're looking at some of their parts to look and see if they are congruent. You've already proven the triangles are congruent, so this is going to be CPCTC. Corresponding parts of congruent triangles are congruent. You proved the triangles are congruent, and now their parts are going to be congruent also. Problem number 14. I set up a little bit on the side here so you can see what's going on. This one is at negative 2, 0. This is at 0, 0. And then this is at 1, 5. So this much, which is 2 apart, is the same as this much for ST, and I got to find U. So really what I'm looking at is going from Q to R. So to go from Q to R, I went 1 to the right and then 5 up. So I need to go 1 to the right and 5 up. Now, if I go from S, I'm actually going to the left, and then I could go up or down. So this one I would kind of throw out. And then this one, if I go from T, if I go to the right, would be if I was looking this way and went to the right, and then 5 down. So then this would be, if I went to the right one, it would be at 7. And then if I went down, it's going to be at a negative 1. But on this one, if I'm go 1 to the right, that would be at 7. And then if I go up 5, because this difference is 5, so then I would be at 9. So this is at 7, 9. 15. If the lines are parallel and these lines are parallel, how would you know that ABC is congruent to that? More than likely, if I'm looking at this, then that means alternate interior angles are congruent because I have parallel lines. And then these alternate interior angles are congruent. And then this is equal to itself. So angle, side, angle would be what I would say. Problem number 16. You have to tell all the reasons here. So WX is equal to ZY, so that's given to you. And so WX is equal to ZY, that's here. And angle 1 is equal to angle 2, that's given to you here, so given. WF, WP, WP is equal to ZP. And because these base angles are congruent, then that means these sides are congruent. So that would be the converse of an isosceles triangle. So now the two triangles are congruent because I have a side, I have an angle on the side. So side, angle, side. And then these two parts, XP, so this is going to be congruent to this over here because of two parts of CPCTC. And then angle 3 is going to be congruent to angle 4 because this is an isosceles triangle. So then the base angles are congruent. So that's because it's an isosceles triangle. Next one. Okay, set up a table. And this is going to be the statements. And this is the reasons. And number 1, BD is perpendicular to AC and D is the midpoint. Of AC. So all of that is given. Now you have a definition here, which is midpoint, a vocabulary. So I got to tell what happens if you have the midpoint. So if I have the midpoint, then it makes these two line segments equal to one another. So AD is going to be congruent to CD because of definition of midpoint. I also have this equal to itself. Can't forget that. So 3 dB is going to be congruent to dB. So that's reflexive. And then I also see I have perpendicular, and try to remember now, when you have perpendicular, you have three things that happen. You mentioned that they're perpendicular. When it's perpendicular, that means it makes right angles. So angle ADB and angle CDB are right angles. And why are they right angles? Because that's the definition of perpendicular. And then the next thing is, because you have right angles, they're congruent to each other. So angle ADB is going to be congruent to angle CDB because right angles are congruent. 6, now I can say that the two triangles are congruent. So triangle ADB is going to be congruent to triangle CDB because of side angle side. And now I can say that BC is congruent to BA because of CPCTC. And then the last one, X is midpoint of AD and BC given. And so if it's the midpoint, it cuts it in two equal segments. So this segment is going to be equal to this segment. So 2BX is going to be congruent to CX. Definition of midpoint. And then also that means that this AX is going to be congruent to DX. Definition of midpoint. And then I have some vertical angles here. So 3 angle BXA is congruent to angle, if I went BXA, I went 1, so CXA, vertical. And in 4, I can say the triangles are congruent. BXA is congruent to triangle CXA because of side angle side. And then AB, 5, AB is congruent to DC because of CPCTC.